Hello, this episode is about a quick overview of classifying machine learning. We'll be learning various types of machine learning, and I want to give a just brief explanation of what those kinds are. I think we have seen this slide earlier. The machine learning can be broadly classified as supervised learning, unsupervised learning, and reinforcement learning, and that is in the big category of artificial intelligence, a more narrow scope of what we call machine. Right? And so let me just briefly mention what each types are. The supervised learning is training a data with many explanatory predictive characteristics, X variables, and there is a correct answer Y variable for each of these observations. And we are trying to train a model that gets as close as possible to the true answer. For example, in regression, we try to find a line that best explains these Y variables, isn't it? So a line passing through will be probably a good answer, isn't it? Okay, and it doesn't have to be a line. So in general, a black box like neural network, you can have an input image, whether it's a motorcycle or not. Okay? And we train the data to basically make a prediction. If it's a motorcycle, give 1. If it's not, to give 0. And during the training process, we do have a correct answer. When there's a picture of a motorcycle, then have 1. If it's not a motorcycle, then 0. And we feed either a motorcycle or not a motorcycle picture, and then try to fit this network in a way that best does it. So it's in a sense that the supervised means that the correct answer is kind of a supervisor. It tells which direction this model should go. Unlike that, there are also unsupervised learning, which does not have a correct answer in the data. So these are just X variables, the explanatory characteristics. For example, banana has certain lengths and widths, and pumpkin has certain length and width. And in general, though in real life, we do have some concepts of what is a banana and what is a pumpkin, but we want a machine to tell basically whether it is or which one it is without actually having to tell banana or pumpkin. So sometimes we train the data in a way that the characteristics by itself can be sort of grouped in a distinct way, especially like in these gene expressions, like these DNAs, can we just group them in a way that has similar characteristics by itself without actually having to tell this is A, this is B, and stuff like that. Another way of this unsupervised learning is dimension reduction, and in a sense that try to capture like these various dots in, let's say, 2 numbers, like the direction of here where the data varies the most, and then the varies the next, and such. Okay. And we'll discuss more about these dimension reduction applications. There are many in finance and other applications. Finally, there is this reinforcement learning. And I think the easiest way to say this, it does not have a correct answer, wrong answer, but it is sort of like we have a model that tries to give a prediction of what action, what a decision is the best to do. And based on that, it does receive a reward, and train a model in a way that to make model that predicts a decision based on how to maximize these rewards. And I think the best answer is training a dog. And so like the dog, if it does the trick that the owner wants, then it gets a treat, which is a reward. And initially it does not do the trick, but after a while the dog figures out that what is a right action to take and to maximize the treats it gets, isn't it? So it's in a sense that it's a trial and error kind of approach, that there is a model and you give the situation over and over again. And in each situation, given an answer, like the decision, it gets a reward, and the model basically tries to predict an answer which will most likely get a reward for even each given situation. And then this is sort of like the backbone of so-called many game playing algorithms like AlphaGo. And I guess another example would be like if you remember the movie Groundhog Day, that Bill Murray lives the February 2nd over and over again and faces a similar situation over and over again. And in the first round, it probably doesn't choose the best actions, but then as it lives the life over and over again, it remembers, oh, in that situation, if I did this, it ended poorly, so I should this time do this. And then after a while, his actions and choices becomes really, really great. And then this is the idea behind reinforcement learning. So these are the 3 types of machine learning that we will cover in the future. Thank you.